Welcome to Trimble Business Center Photogrammetry. In this video series, we want to show you how to run drone processing in TBC, and we will use for this video series the Trimble Business Center tutorial data that you can find here on the webpage. Please feel free to navigate here to this webpage, and then you will find, when you scroll down, a chapter that is called Working with Aerial Photogrammetry. Download all of these free datasets because we will use all of them, and we will go step by step through them and explain how these functions or parameters work, and hopefully this will help you to get easier done your work in TBC. Each dataset here has its own camera. So the first one is using a Trimble camera. Unfortunately, we have a typo here, so this is the X100 from Trimble for the first dataset. The second dataset is using the Trimble UX5 HP high precision, and the third one is a DJI Phantom 4 RTK sensor. The TBC supports a specific amount of cameras, and we want to support the most common cameras used on the market, and for them we are preparing during import that we read the metadata and all necessary informations automatically out of the input data, so that you can really, in a very simple way, process the data in Trimble Business Center. So let's take a look at the download from the first dataset, processing aerial survey data. And when you take a look and when you extract the file, you will find a PDF. And this PDF is a step-by-step instruction how you can run the data in TBC. So the video here is a complementary part. We want to go in more detail about all the different steps, explaining things that are here written in the step-by-step instruction, or perhaps take an X course and explain something a little bit more in detail. But you can also just go through the PDF and finish the dataset processing in TBC itself. We will use the PDF somehow as a guide, so we will then try to follow these steps a little bit in a similar way. So that means you can use also the video to help you get this data processed in TBC. Additionally to this, you already have, for some of the demo data, already an existing Trimble project file. So you can also here, depending on from the PDF, use this already to get your project started. In our case, we are also looking here into the data, and in the data, when we take a look, we will find our images inside. So in our case here, these JPEG images, these are our drone images. And for some of the sensors, which have been introduced at the beginning of Trimble Business Center for drones, these files have to be imported via a JXL file. So this JXL file includes a lot of information about orientation of each of these single images. So when we take a look, for example, on this JXL file, we can see here there's a camera definition, and we can see here in the camera definition the pixel, the sensor itself. So these are the pixels in width and height. We also have a pixel size. So our drone here has 2.0394 micrometer for 1 pixel size. We also have a focal length, which is 6 millimeter for this one. We also have a distortion model that is typically done by these orders of 3, 5, 7. Typically also a 1 is normally included. And just as I mentioned here, just that we see it here, so this camera is a Gatewing X100 that was working with Trimble together to be imported into TBC at the beginning when we started to support drones. So for each photo, we have then additional informations and of course one of them is the position. So we have here in WGS 84 the latitude, longitude, and height for each of our photos. And when we take a look back here, so that means each of this JPEG image, we have already here a position. And this position is less or more accurate. This is depending from our GNSS quality that is built in with this system. And therefore, very common, we call it a UAS, unmanned aerial system, because it has the camera. It has built in a vehicle in the drone itself. And then we have for the whole vehicle with the camera a position via GNSS. And so this is then this complete system in this case. The GXL file is a Trimble file, and it allows us in a very flexible and complex way to bring in drone data. But with the ongoing on of development of drones, so we always try to contact the vendors of the different drones, and we try, of course, if it's possible, that they provide GXL files. So GXL files are also, for example, possible to be done from SenseFly and from Wingtron. But in the upcoming futures, more and more, we want to be able to handle default data that you can run in a standard photogrammetric run. And so we tried now to support for the common sensors like for DJI or for micro drones now, and also in the future for systems that are very well established on the photogrammetric market, to directly use the data they provide and to bring it into a TBC. We will take here a closer look later on the third data set, which is the processing of DJI aerial survey data, where now when we look into the data itself, where is here our images in the raw file, there are now only the JPEG images, and we also have here for baseline processing the timestamp and PPK raw data in the RINEX file. And for this additionally, we have now here a T02 file for our base station, where we can then also calculate in Trimble Business Center the baseline processing of the trajectory, which is really a nice feature. Yeah? But again, this is now additionally now to importing just the raw images. So we just would need the images itself and to import the data into TBC, which is then easier now for people that or for drones that are not providing the JXL file. Each project includes also ground control points, because we want to show you also how to measure ground control points, but also ground control points help us to improve the quality of our results. And finally, also, as this video wants to go a little bit more deeper, we will also use one free viewing tool. So on this part, I will open very often with Irfan View data. So feel free to use this tool also if you want. The advantage of the Irfan View is if you hit the I key on your keyboard, and after you hit I, you hit E, like EXIF information, we can access the EXIF tag of JPEG images. And this is something which is used very often in our import, that we will scan through these informations here and then extract from here information or check information from the EXIF header. And therefore this makes really work easier for us here, just that we can then always compare or see what is written here, what is used here. So for example, very often in the EXIF header, we will take a look here at this information of this GPS tags. And then also what is nice in Irfan View, You have here a show in Google Earth functionality, so you could then see where is this located with a height. And secondly, also what I'm also very often using it is here are more options, which includes the geohack part. And the geohack has the advantage that I can see the general UTM zone. So this data here is located here in UTM 10 north in this case here, and then we can here see this is very close here to this area here located. Therefore, it gives us also a general UTM coordination. We will not use for this one the UTM, so this is here in Wyoming, so we will use a Wyoming coordinate system for it. But again, it's a nice thing to use it here to check the informations that are given. Another thing that we will also use is just a standard editor. So we can here open, I use here this Notepad++, and in the Notepad++, when I open it, we can then make a search with Control and F, and then I search for XMP, and then we can here in this binary file, there's a ASCII area, and we can check if the data includes XMP text. This is very interesting, mostly for DJI data, and these are here metadata informations that are really important for photogrammetry, so we can here check very important entries. One is very important is, for example, the RTK flag information. So here there's a code, it's a DJI driven code, it can be 16 or 35 or 50, and 16 means it's not post-processed, it's raw data, which means the data is only around 5 to 10 meter accurate in position. Then we have here, or I think it's 34, this is then a floating solution, which means the baseline processing or the post-processing was not completely fully successful, so the data can vary something around 1 meter or something like that. Or when it's a 50 RTK flag like here, then this was a fixed solution in the baseline processing, and therefore this data can have centimeter accuracy. I would not now really take here this RTK standard deviations, but they are centimeter accurate. Other interesting entries are, for example, the relative altitude or the height above ground, and also interesting is the DWARP flag information about DJI data. Also very typical for professional drones for photogrammetry is that more and more it's common that they have a unique model name. So for DJI, for example, for the DJI Phantom 4 RTK, the model name is FC6310R, and this model name here helps also to clearly define what sensor we are working here with. Okay, so I hope this helped you a little bit to see the bigger picture. So what we will do is really now work with the free tutorial data sets, and so we will run with the X100, the processing aerial survey data. We will start. Then we will also go through the UX5HP dataset, and then finally also with the DJI Phantom 4 RTK, and there explain more details about photogrammetry. So I hope you will enjoy this series, and we will then see you in the next videos. Thank you for watching. Bye.